Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is it's March 6, 2025, and the time is 12:06 a.m. Okay, my topic for tonight will be a continuation. It's a continuation of my long video format analytic geometry. I haven't lectured on the long video format for the past weeks. I've been busy doing some short videos on electronics and other things. So for tonight, I will be continuing my long video format topic, analytic geometry, and we are now on lesson number 24, or I am now on lesson number 24. Okay, let's proceed. The title of the topic for this morning will be Analytic Geometry, lesson number 24, and the title of the topic will be Circle Example Problem. This will now be number 2. This will be the second problem with regard to the application of the concept of the study of a circle. Okay, I will try to read the problem. Find the center and radius of a circle with the equation. The given equation is 1/4 x squared minus 5/4 x plus 1/4 y squared plus 9/4 y minus 3, and they should be equal to 0. The problem is just asking what will be the center of the circle and the radius. If we see the center of the circle, it will be the coordinates of the circle, meaning we must have to compute for h and what will be k. Because for sure, the given circle is not at 0, 0, meaning h equal to 0, k equal to 0. Okay, for the given equation, supposed to be it's not. The value of h and k is not equal to 0. That's why the problem is asking for the coordinates of the center and what will be the radius of the circle in terms of units. Okay. Okay, let's try to bring out the solution. The key to the solution of the problem is that we must have to know the equation of a circle with center at its k. And actually, before I will discuss the solution, I will try to give you the equation of a circle with center at its k. This is the equation of a circle with center at its k. There is an h, there is a k, and these are the coordinates of the center. And the problem is asking what will be h and what will be k. On the right hand side, there is the value r squared. That's the radius quantity squared. So actually, the problem is asking for the value of h, for the value of k, and for the value of r. So the approach to the solution is that by knowing this one, okay, we could devise a plan on how to go back to this equation here. With the given equation is actually the expanded form. It's a quadratic equation for both x and y. So we must have to use our knowledge of algebra to bring this equation to this form here. Okay, so we could compute for, or we could specify the value of h, the value of k, and the value of r. Okay, let's try to rewrite the given equation. This will be the given original equation. 1/4 x squared minus 5/4 y plus 1/4 y squared plus 9/4 y minus 3 equal to 0. I will place this one in open and closed quantity. Okay, and I will multiply all the terms by the value 4. Okay, I feel agitated with the fractional component of the coefficient, right? Because this is 1/4, this is minus 5/4, this is again 1/4, this is 9/4. Okay, it looks ugly, right? So we must have to eliminate this for here. And to eliminate that one, like what I said, we have to open the enclose this with open and close quantity, and we will multiply this by 4. So if we try to distribute this for here, this for here eliminates this one here, eliminates this one, eliminates this one, eliminates this for here, but this 3 here should be multiplied by 4. Anyway, the right hand side is 0 multiplied by 4 will still be 0. Okay? So after the multiplication of the 4, the resulting equation now will be looks nicer or more beautiful than the original, right? Because we eliminated the denominator. So what will come out will be x, just simply x squared minus 5x plus y squared plus 9y. 3 times 4 will be negative 12. Like what I said, 0 times 4 will be equal to 0. Okay, I'll try to check my camera. Oh, it looks fine. We are now given the expanded form of the given equation without the denominator. So how could we transform this one to this? It is actually by completing squares. Okay? We must have to find the constant to be added to this first term here and the constant to be added to the y term here for both the x and y to be a complete binomial or a perfect binomial. Because a perfect binomial, if we try to expand it, okay, it will be of this form here. Okay, so for x, we needed the coefficient of this x here, and the coefficient is actually negative 5. And under the rule, under the completing squares, we will take the coefficient of this x here, we'll multiply it by 1/2, then we'll try to square it. So this will be minus 5 halves square. So 25 over 4. For y, we'll take the coefficient of the y term. The coefficient of the y term is actually 9. We'll take 1/2. We'll take the square of it. So it will become 81 over 4. So these are the needed constants to complete the squares for x, okay, and for y. So adding this 25 over 4 and 81 over 4 to the left hand side, it will become, I will rewrite the given original equation for x, that will be x squared minus 5x. I will add up 25 over 4 to make it a perfect binomial later on. Plus I will rewrite y squared plus 9y. And for the y term to become a perfect binomial later on, I will add up 81 over 4 as per our computation. Right? So I add up 81 over 4. And they should be equal to, as a Ronlin algebra, okay, whatever you add on the left, it should also be added on the right for us not to change the value of the equation. So we added 25 over 4 here. We added 81 over 4 here. So we added 25 over 4 on the right hand side. We added 81 over 4 on the right hand side. So it is just balanced, right? So after the addition of this 25 over 4 and 81 over 4, okay, we can close this one now with an open and close quantity actually. Right? This will be a whole expanded form. And this whole expanded form is actually the square of a binomial x minus 5 halves quantity squared. If we try to square this one, the expansion is this one. Okay? And if we try to, the binomial equivalent of this one is actually y plus 9 over 2 quantity squared. Because if we try to expand this one, what will come out is this one. But this could be factored to a binomial y plus 9 halves quantity squared. Okay, a perfect binomial And for the right hand side, we are adding fractional number and whole numbers. So we must have to multiply this by 4 over 4. So the common denominator now will be 4. So 12 times 4 will be 48 plus 25 plus 81. Okay? And this should be equal to 154 over 4. Okay? And I could rewrite this 154 over 4 to be the square root of 154 over 2 quantity square. If we try to square this one, it is this. Right? So this is now the resulting equation after completing squares. And this is actually similar to the equation of a circle with center at its k, that is x minus h quantity square plus y minus k quantity square equal to r square. So in here, we could solve for h now. We could solve this by inspection, but I prefer to bring out the solution for it. X minus 5 halves should be equal to x minus h. Okay, x minus 5 halves is equal to x minus h. So I equated x minus h is equal to x minus 5 halves. Actually, this x here cancel with this. What will come out will be negative h equal to negative 5 halves. Negative, negative, it's look actually. We'll multiply this by negative 1. Negative, negative will now be positive. This negative 5 halves times negative 1 will be 5 halves. So the unknown value of h is actually 5 halves. Okay. On the k side, or on the value of k, so like what I said, solving for k, y plus 9 halves is actually y minus k. And this y here actually cancel with this. So minus k is equal to 9 halves. We must have to solve for the value of k without the negative sign. So we must have to multiply this by negative 1. Negative k times negative 1 will be positive k. And 9 halves times negative 1 will be negative 9 halves. So the value of k will be negative 9 halves. It's a negative value. This is a positive value. So the center of the circle is actually the coordinates. Is actually at 5 halves and negative 9 halves. And for the value of the radius, the radius is actually this one here. The one inside the quantity is actually the radius. So radius will be equal to the square root of 154 over 2. And if we try to bring out our calculator, square root of 154 is actually around 12 something. Because 144 is 12, right? Divided by 2. So 12 something divided by 2, that will be 6.2 units. So the radius of the circle is actually 6.2 units. Okay, sorry for the figure guys. We lack space already. I will try to check my camera again. I bring out the figure. This should be the x-axis. This is the y-axis. If we try to locate the center of the circle is actually at this point here. The coordinates will be, this is 2.5, 5 halves is 2.5. Okay, and the value of k is a negative value, so it should be below the x-axis. And this is negative 9 over 2, negative 4.5. So the coordinates of the center here is actually 5 halves and negative 9 halves. This is the center of the circle. This is on the fourth quadrant. And the radius, sorry for the radius guys, it's not too accurate already, we lack space. So this should be 6.2 units. This is 6.2 units. This is 6.2 units. This is 6.2 units. And the equation of the circle here is the given equation. 1/4 x squared minus 5/4 x plus 1/4 y squared plus 9/4 y minus 3 equal to 0. That's the equation of the circle with the center at 5 halves and negative 9 halves, and the radius is actually 6.2 units. Okay, it's an easy problem if you know how to use your algebra. So the emphasis here is always the lower mathematics is algebra. Because without knowing the so-called completing squares, we could not solve for the problem. Okay, that's it guys. So for those of you who would like to watch my channel is at youtube.com/@ProfDBJTilusReyes. If you want to share it, please click share. For those of you who do not know that my channel contains long video format topic discussions, I just would like to reiterate or repeat it for tonight. The other long video format topics that I have done is differential calculus, integral calculus, differential equation, advanced math, DC circuit, AC circuit, algebra, and trigonometry. Those are the long video format topics that I have on my channel. For the short videos, it's a combination of electronics topics because I'm also a troubleshooter. I know how to troubleshoot up to the component level, and I know how to, what you call this, work on a circuit, actual thing, like soldering and troubleshooting. So what I'm doing on my short videos, I try to emphasize how to do some things on electronics, okay? It could be a security thing maybe, or it could be what is so-called assembly of a circuit using soldering and of course your knowledge of the familiarity of the electronic components. Those are the topics under my short videos. But the main concentration of my channel is actually on the long video formats because I want to give students the thorough knowledge on how to study differential, integral, differential equations, and other things. Okay, that's it guys. Good morning from Los Angeles. This is Professor David J.